Okay guys, this is number 19. We're still on worksheet number 1 for our sequences and writing our explicit formulas. And again, you're still trying to write things in the same type of format, and you're still trying to write things so that you can see things that are the same and see things that are different. Now, you have fractions, so immediately we're going to start thinking about, oh, well, this 1 over 1 has to be rewritten, it's going to be some type of fraction, we're going to have to figure out what it is. Now, I see that we have a 4, oh, sorry, I meant to do, there we go. I see that we have a 4 and then a 2 and then a 4 and then a 1. I'm really thinking that's like, we're either going to alternate 4, 2, 4, 2, or we might want to write everything in terms of 2. We might want to write everything in terms of 4 as we're going. So a couple of things that we can start looking at. So if we're thinking the whole alternating, so we're not really going to do anything. And some of this is trial and error. We leave a 2/3 here, and we do, oh, that's a 3. And we do a 4/7, and then if we wanted to rewrite that final fraction with a 2 on the top, we'd do a 2 over a 4. So that would let us have alternating, and then we would have actually changed this to a 2 over a 2. So that we then have 2, 4, 2, 4, 2, which, doesn't actually help us too much, but it's just something that we're trying. Now then when you look at that, if we keep that whole alternating items, we got a 2, a 5, a 3, a 7, a 4. So we added 3, we subtracted 2, we added 4, we subtracted 3. No, that's going to be too much. So get rid of that, right? And there is going to be some, crazy scrap paper that we're going to have to work through, and that's fine. So then let's try and see if we can, and here's the thing that I look at. I see 4 over 5, it's not reduced. But 2/3 and 1/2, if you look at them, we're so used to reducing our fractions, we don't think about the fact that when we see a fraction that's already reduced, we could actually make it bigger, right? So if 1 over 1, there we go. So leave that alone for now. My second term is still 4/5. My third term, I'm actually going to, because I have a couple of 4s right here, I'm going to see if I can rewrite my third term with a 4 in the numerator. And if I do that, well, really all I'm doing is multiplying my numerator and my denominator by 2. So this is actually going to be 4/6. Then I have 4/7. Look at that. I got a 5, 6, 7 underneath there. And then if I do the same thing for that last fraction, that same treatment, I want a 4 in my numerator, it's going to be a 4 over an 8, right? And so then ultimately, that looks really good because I have 4s for the last 4 fractions here, and I have a 5, 6, 7, 8, and that's just adding 1 every single time, so that's an arithmetic sequence down in the denominator, and really, that 1 over 1 can be rewritten as a 4 over 4. So now, to write my actual term, a sub n equals, all right, I've got my 4, and again, I left our answer there so that we can always kind of work back from that. So we have a 4, right? That's the thing that is the same in all of them. And then if you look down here, right, we can do an arithmetic sequence. Our first term was a 4 plus n minus 1 times our difference was a 1, right? And so we do our little bit of arithmetic. I'm actually going to work up. So I have a 4 plus 1n minus a 1, okay? And so when I combine my like terms, my 4 and my -1, I really have an n plus a 3. Okay, and we're doing this for n greater than or equal to 1. So that's how we get to there.